Are you confused about how AWS Target Groups work with application load balancers, ALB, and network load balancers, NLB? In this video, we break down everything you need to know, from choosing the right target type to configuring health checks, stickiness, and weighted routing. Whether you're building with EC2, ECS, Lambda, or on-prem targets, mastering target groups is essential for high availability and smooth traffic routing in your AWS architecture. Decoding AWS Target Groups configuration tips for ALB and NLB. When using AWS load balancers, whether application load balancer, ALB, or network load balancer, NLB, target groups act as the critical connection layer between your load balancer and backend services. They manage which compute resources receive traffic and how that traffic is routed and evaluated. Let's dive deeper into how target groups work and explore best practices for configuring them with both ALBs and NLBs. What are target groups? A target group in AWS is essentially a collection of endpoints called targets that can receive traffic from a load balancer. These targets can be EC2 instances, IP addresses, or even AWS Lambda functions depending on the load balancer type and the use case. Each target group defines the protocol HTTP, HTTPS, TCP, etc., the port on which traffic should be sent, and health check settings that help the load balancer determine which targets are healthy and eligible to receive traffic. How target groups behave differently with ALB and NLB. Application load balancers ALBs operate at layer 7 of the OSI model, which means they can make decisions based on the content of the request. This includes things like routing requests based on URL path or hostname. Target groups used with ALBs support a wider range of protocols such as HTTP and HTTPS, and they can also route traffic to Lambda functions, which is especially useful in serverless architectures. Network load balancers NLBs, on the other hand, operate at layer 4. They're optimized for ultra-high performance and can handle millions of requests per second with very low latency. Target groups with NLBs usually support TCP, TLS, UDP, or combined protocols like TCP_UDP. Because of this, NLB target groups are ideal for use cases like gaming servers, real-time messaging, or large-scale APIs that require very fast throughput and minimal overhead. Best practices for configuring target groups. 1. Choosing the right target type. When creating a target group, AWS lets you choose among 3 target types. Instance targets are specified by their instance ID. This method is simpler but limits flexibility in networking scenarios. IP, you specify IP addresses directly, which is useful when targeting services outside of EC2, such as on-prem servers or containers with dedicated IPs. Lambda, available only for ALBs, this allows routing directly to AWS Lambda functions, enabling powerful serverless workflows. If you're working with containers on ECS and using the OSP networking mode, you'll often need to use the IP target type. This gives each container its own IP, which makes routing and scaling much more flexible. 2. Defining health checks properly. Health checks are how your load balancer knows whether a target is healthy and can handle requests. Misconfigured health checks can cause healthy targets to be marked as unhealthy, resulting in dropped traffic or even downtime. For ALBs, health checks are done over HTTP or HTTPS. You can define a specific path such as /health that your application uses to return a 200 OK response when it's operating correctly. Make sure your application responds quickly and consistently on this path. For NLBs, health checks are typically done over TCP. The NLB simply checks if it can establish a TCP connection to the port. This is less detailed than HTTP checks, but it's faster and sufficient for many use cases. Be mindful of the interval, how often to check, timeout, how long to wait for a response, and healthy/unhealthy thresholds, how many successes or failures are needed to change the health status. 3. Using target group stickiness, ALB feature. Stickiness, or session affinity, is a feature that allows an ALB to bind a user session to the same target throughout its duration. This is especially useful for stateful applications such as shopping carts or user sessions that are stored in memory. You can enable stickiness in your ALB listener rules and configure how long the stickiness lasts. Keep in mind that this is only available with ALBs, not NLBs, and it's disabled by default. 4. Traffic distribution with weighted target groups. In more advanced architectures, you might want to send only a portion of your traffic to a new version of your app, such as during a canary deployment or a B test. ALBs allow you to forward traffic to multiple target groups, and you can assign weights to each group. For example, you could send 90% of traffic to the stable version of your service and 10% to a new release. If the new release performs well, you can gradually shift more traffic to it. This gives you precise control over deployment rollouts and rollback strategies. 5. Understanding deregistration delay. When you remove a target from a target group, AWS doesn't stop routing traffic to it immediately. Instead, it waits for a period called the deregistration delay. By default, this is 300 seconds, 5 minutes. This delay helps in ensuring that in-flight requests are not interrupted and that connections close gracefully. However, if you're deploying frequently or need faster failovers, you might want to reduce this delay to something like 30 or 60 seconds. You can adjust this setting based on the behavior of your application, particularly whether it can handle connection termination cleanly or not. 6. Ensuring proper security and networking. A common cause of issues with target groups is misconfigured security groups, SGs, or network ACLs, NACLs. Ensure that your target instances allow inbound traffic from the load balancer's security group on the correct port. Also verify that the subnets associated with your targets are correctly configured to allow return traffic. If your architecture is internal, non-internet facing, consider using VPC endpoints or AWS Private Link to route traffic securely between services inside the AWS network without exposing them to the public internet. Common use cases. Web applications, ALB paired with EC2 or container targets using HTTP/HTTPS protocols and advanced routing rules based on URL paths or host names. APIs requiring high performance, NLB with IP targets and TCP protocol for minimal latency. Microservices architectures, ALB configured with multiple target groups and path-based routing to route traffic to different services. Serverless backends, ALB routing directly to Lambda functions enabling powerful event-driven architectures. Common pitfalls to avoid. Not aligning your target group's health check settings with what your application actually returns can result in healthy services being marked as unhealthy. Using instance-based targets with ECS in OSPC mode will fail. Switch to IP-based targets. Failing to reduce deregistration delay during automated deployments can cause delays or interruptions. Overlooking listener rules and forwarding logic can lead to requests being dropped or sent to the wrong service. Final thoughts. Target groups may seem like a small piece of the AWS networking puzzle, but they are foundational to making your load balancing strategies reliable and scalable. Choosing the right target type, configuring health checks properly, and understanding how ALBs and NLBs treat traffic can make a major difference in performance, resilience, and deployment agility. Mastering target groups gives you better control over your infrastructure and the confidence to scale your applications gracefully in production. Don't forget to like, subscribe, and hit the bell for more AWS deep dives.